Okay, I'm going to record, and I've got Matlab running. All right, I haven't touched this since I sent it to you, so hopefully this works. I just type in, oh, actually, let me go up here. Wetsuit2020. I'm going to just for now change this to 1 velocity and 1 trial to process. And then I'll show you, and I'll walk through a bit of this code here so you understand that part as well. All right, to run the Matlab program, I just type in the name of the program or name of the script file, which is Wetsuit2020. Hit enter. And first thing it's going to do is read in the MVIC files, and it's going to normalize EMG to MVIC. This is repeated measures, so the normalization isn't that critical, but it does give a sense that 100% EMG is the same across subjects. There's always problems with doing MVIC, especially of muscles like the anterior deltoid and posterior deltoid. Those are not easy muscles to get MVIC for. All right, this is a little slow to run the first time, and being on Zoom, it's all right, so it's processing file, subject 1, condition 1, velocity 1, trial 1, normalizing the EMG. And the first graphs that will come up will be from the MVIC files. And then what I do is I write a routine to find the greatest 1-second average within the data set. And so this is opening up the anterior deltoid MVIC. Yeah, this is slow. There it is. You can see the figure coming up.
Mm-hmm. It's starting to.
There it is. Okay, so now I've got EMG. This is raw units. So this is voltage over here. And then this actually isn't time. This is row number. To get time, I have to divide by 2,000, the sample rate. So this is 7 seconds out here, 8 seconds, 9 seconds. So then this red line represents the greatest 1-second average. So all I do is I look at, because the sample rate is 2,000 hertz, look at 1 second, calculate the average, then I advance it 1 data point, calculate another 2,000, the average over another 2,000 points. And I do that for the entire set. And then I go and find the greatest 1-second average, which is probably somewhere right around this region or maybe this region over here. That's for the anterior deltoid. We'll go to the next one, which would be the posterior deltoid. Yeah, this runs a little slow. And then I use this to say this is, whenever we see this voltage, we call this voltage 100%. And we'll do the same thing for the posterior deltoid here, posterior deltoid EMG. This represents now 100% EMG, this red line. So wherever we see this voltage, we'll understand. Now, it's important in EMG, this 1,000 units of volts does not correspond to the 1,000 units of volts in the anterior deltoid. It does not. But the change in voltage between one voltage and another voltage will be the same. So this voltage is twice as much as that. That's what's important. Okay, not the 500, not the 1,000. That's why we normalize. So everything just becomes a percent of something. In this case, the percent of something is MVIC. All right, so now you get this plot. Let me zoom, let me blow it up here. And what I have here, when it catches up, are 2 columns of graphs. This is the anterior deltoid data, and this is the posterior deltoid data. The first row of plots is EMG and percent EMG. The next row is the accelerometer in the X direction of the sensor. So wherever we put that transmitting unit, then the accelerometer in the Y, the AZ direction, and then this is just resultant. So X squared plus Y squared plus Z squared, and then the square root of all that. All right, so what I did to start off with is I said, okay, we want to find the pattern of this EMG up here. All right, so this is clearly a nice little pattern to see. This one, there's a pattern, but a little harder to see it. Sorry, dog's barking. This one's a pretty good pattern. This is a little harder to see down here because we're getting a mixture of these, but the X is pretty clear. And so all I did just to start off with is I said, okay, I'm going to use the X accelerometer pattern to find the cycles. Now, I just said, let's find 5 cycles, which is 6 clicks. So I have to click on that. I click on that one. I click on that one. That's 4, 5, 6. That's 5 cycles. 1, 2, 3, 4, 5. And you can see where these red lines exist everywhere else. Those are the data that we're going to extract for analysis. So going up here to this one here, we can see it almost starts where that EMG is the minimum. It doesn't, almost starts more with the peak here. Now, we could use another discrete event like minimum value here, or we could go to one of the other dimensions. And that's ultimately what I want you folks to do, is look at each of the files and then try to figure out what's the right marker to identify the pattern. Now, all I want is the pattern. All right, so when we look at running, we start typically at the heel strike, but we're not constrained to that. We could do toe off to toe off. We could do mid stance to mid stance, mid swing to mid. We could do any of those. It's just convenient to do heel strike to heel strike. All right. So right now I just picked out this peak. All right. So now what I'm going to do is I'm going to extract EMG data between these 2 bars and call that cycle 1. I'm going to extract EMG in these 2 bars. Call that cycle 2, cycle 3, cycle 4, and cycle 5. I'll do the same thing for the posterior deltoid. But I'm using just these peaks to create all those red lines. Okay? All right, so now I'm going to hit enter. And I'm going to get a new plot and oh, okay. Unrecognized variable. What did I do? Line 10, I must have subjects to process. Line 10, wait. I must have typed something and changed it. Extract. Yeah, that's not supposed to be there. Check your Wetsuit extract 2020. I must have been typing too fast somewhere and ended up putting something there.
I don't think you posted that M file.
What's that?
I don't think you posted that M file unless I missed it.
Wetsuit extract 2020?
I don't think so, but
I did not. All right, so let's put that in there. How did I miss those?
yeah, I tried to make that before our meeting, and that was the one file. Like it stops there for me.
Okay. copy that over. Okay, it's in there now. And now let me just run it again. So it should go faster the second time around. Same thing, same thing. And here's the cycles again. I'll pick out 6. And I'm not going to start with the first one because that first stroke is always going to be a little different. And I just need to click near this peak. I don't have to click exactly on it. Okay, there's the 6. And now what I have are what we call ensemble. Well, we're getting set up to make an ensemble plot, which is just an average plot. So I've got 0 all the way over to 100. So what I'm doing is I'm making each cycle 100% time. So even if one cycle is a little shorter than the other, I still make it 100%. Okay, so from the peak acceleration to the very next peak acceleration is some absolute time, but then I turn around and make that a percentage. And then I can plot all those data points on the same plot. So each color here represents one of the cycles. So there's going to be 5 cycles in here. And now I can see, well, there's a nice pattern, general pattern here. Okay, all the cycles did, well, there's some peak around here and then another peak over here. And, you know, same thing, I can look at each of the acceleration signals as well. The PD, okay, well, it's a little bit different, but they tend to group together. And so then we would create an ensemble plot or mean muscle activity for this subject condition velocity trial. Okay, now you hit space and then I'm done. And then it actually saves some of the discrete values on top of that. So now let's say I wanted to run more trials, and I know I've got 3 trials here. I just go back and I change the information here. So this is, if you're going to edit this program, this is usually where you're going to be changing things. Subjects to process, how many? In this case, I'm going to do 1 subject. Conditions to process, right now I'm just going to do 1 condition. Velocities to process, right now I've just got set to do 1, but I'm going to change it to 3 trials. Now I can run all these together, but I'm just going to do this to show you. And then I can also change which subject to start with, which condition to start with, and which velocity or which trial to start with. So if I just wanted to run 1 trial, subject 4, condition 3, trial 2, I just need to update all of this to be 1, and then I need to change these to the exact file that I want to point to. Okay, so I'm going to save that, and I'll run it again. And it's going to normalize the data. And what's good is I only need to do this once per subject. So you're not going to see it every time that we do this for all the other trials. Because once you have your MVIC data processed, then you just apply it to all the other data points. All right, we already looked at this plot, and now this is going to go ahead and do trial 2. And now I go ahead and go in, and I click on my 6 cycles again. This is the next file. And I always plot out my raw data, and that's what these are. Because I want to be looking at the integrity of the EMG signal, how good this EMG signal looks like as well. So there's a bit of qualitative filtering of the data. And if we start to see some really weird spikes or the data just look really awkward, we need to note that and then come back and figure out whether or not the data are any good to process. Here's the ensemble plot, the interpolated data set. Good pattern here. Something weird happened on this one, but that gets drowned out with the other trials. And then the PD is still sort of a weird thing. Oh, interesting. I've got my scale. I've got to change that. This is not It should have been in percentages. Interesting. Okay, I've got to go back and look at that. And then we're going to come down here. And, we're doing 3. Okay, so I'll do one more. And again, I'm inspecting the quality of the data, not only from what I'm clicking on, but then also the EMG files or EMG portions of this. These look like nice bursts. This PD is still, I don't know, but that's okay. I mean, it may be that the PD is just not very active. Nice burst here, nice burst here. Something happening in the middle of PD that seems to be consistent. And now we're done. Okay. Now I do get some other data points out of this. And you have to have your input files in the right spot. Create an output folder, and now I get these files generated from the program. Each of these is the interpolated data for one cycle within that trial. That's what this is. And that's going to be interpolated data for EMG, AX, AY, and AZ for the AD and the PD. So there should be 8 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What am I missing here? Resultant. So then it's the resultant as well. Okay. So I generate those interpolated files, and then I also generate average EMG. And I've got something happen here. This should be showing different. I got to fix this. This is only showing 1 row of data, but it should have 3 rows of data that we actually processed. So I'll double check why that's not happening. That should have been fine. All right, but it generates these output files. So what I want us to do is to go through the files. I just want to look at them and look and see if the X accelerometer direction does a good job of pulling out patterns. And if it does, then we can report that in a manuscript, and we can say the acceleration in the X direction were used to generate cycles, or used to identify the cycles. Or maybe it's not the X direction, maybe it's the resultant, or maybe the Y or Z, or maybe we don't use that at all. Maybe we use something else. I built that off the X only for this subject, for this data set, and that may not be the best way to do it. But the only way to know is to go through and look at every file. Okay. All right, does that help?
Mm-hmm.
So does your program run now?
I haven't tried. Let me try.
That sounded like a no.
Yeah, so in the Wetsuit EMG extract, mine's a different line, number 19. I have to pull it up.
Yeah, there'll probably be multiple red lines of text. And the art of working in Matlab is trying to figure out which line to look at.
So it says my line 19 has an issue on the extracts.
What are the other red lines say? Can you maybe share your screen?
Can you see it?
Yep. Okay, so undefined. Okay, so you need alter G interp. That's the next M file you need. Let me get that. Hold on. Okay, putting that in the shared drive, go ahead and move that to where your M files are. There it is. All right, try running it again. And that's a very common, when we start sharing programs, that's a very common error. You see 3 lines of code or errors there, but undefined function usually means you don't have the M file. All right, cannot change directory to, okay, so that output directory needs to exist. Let's go to your Baumec. Yeah, and just add a new.
Do I need to put it under?
Nope, just right there, I think it is. Double check. I think that's right, yeah. Run it again. Don't even worry about the other code, other errors, because you've got to find the one error that actually matters.
Yay.
Yeah, that's good.
Yay. It worked.
Awesome.
Let's see.
So now you can start parsing the files, and don't worry about even where you click. You know, sorry. We aren't going to use the data that you're processing right now. All I want to do is identify a good way, a good set of criteria to indicate the beginning and ending of the cycle. And right now I just have AX for the AD. And as you start looking at the other condition data as well as other subjects data, that's what we're looking for, is whether or not that's a good way for all. So don't even try to interpret the data yet. This is still just exploring how to process. Okay.
Yeah.
All right, I'm gonna